Hello! Today we are going to work through implicit differentiation. So, implicit differentiation is when y is not explicitly defined, and we may not know how to take the derivative. So, let's say we take a function or relationship y cubed minus x squared equals 4. Now, y is the dependent variable, but we may not know how to take the derivative. So, we use implicit differentiation. Now, this should make intuitive sense, what we're going to do. So, we're going to take the derivative for both sides, and this can be broken up into two, so it's dy dx of this minus dy dx of this x squared, and that's just equal to the derivative of 4, which, remember, as the derivatives of a constant is just going to be equal to 0. So, let's do that. Is going to be equal to 0. Okay, this part should be pretty easy. As you know from the power rule, derivative of x squared is just 2x, and I proved that in earlier videos. So, 2x, so that's just going to be minus. Okay, so this is going to be a bit more complicated. So we're going to have to use the chain rule to solve for this. Okay, so with the chain rule, we can determine that it is dy dx times dy cubed dx, and that should make intuitive sense. Times. Okay, so what's dy dx? Well, that's just going to be the derivative of y. Now, derivative of y cubed, that is just going to be equal to 3y squared. And I hope that makes intuitive sense, so it's just going to be 3y squared minus 2x equals 0. Okay, so now we have the derivative, and that there's just another way to write a derivative is by doing that little I think it's a quotation mark, but anyway. Okay, so now we're gonna redo this. It's y prime times 3y squared equals 2x. I just added 2x to each side. Now, since we want to get the derivative, we are going to divide by 3y squared on each side. So that will just come out to be that, let me switch colors, y to the, oh yeah, sorry, not y to any power, it's just the derivative of y with respect to x is equal to 2x divided by 3y squared. Okay, now we could leave it at that, but let's say we want the derivative in terms of x. So we are going to have to solve for y. So first we add x squared to each side, so that y cubed is equal to 4 plus x squared. Now we just take the cube root of each side so that we make it into a normal function. Y equals the cube root of 4 plus x squared. Okay, now we can plug that in down here so that we can get y, let me do it over here, that y prime is just equal to 2x divided by 3 times the cube root, I wrote it large enough, of x squared plus 4. Oh yeah, and this is squared. So that's just, now we just can square the inside, so that's going to be x to the 4 plus 8x squared plus 16. And that, I hope that makes intuitive sense. So then we're going to multiply that by 3. Wait, sorry. And that's under the cube root symbol. And oh yeah, so let me read it right. This is pretty messy. So let's rewrite it over here in terms of x. So we have that y prime, the derivative of y, is just equal to 2x divided by 3 times the cube root of x to the 4th plus 8x squared plus 16. Okay, so there we have it. So now let me show you what we can do for so let's say we have y to the n plus x to the n equals c, a constant. So now we just have to do this as, let me switch colors again, y prime times n times y to the n minus 1 power, that's just the power rule, plus n x to the n minus 1 equals 0. So that's basic. So then when we add or subtract this from both sides, we get that y prime times n y to the n minus 1 equals negative, actually, let's make that r, since they can be different numbers, so that's just going to be r times r. Really hope I didn't confuse you. It was kind of confusing. Times x to the r minus 1 over y. Oh, well, yes, and then we can divide each side by n y to the n minus 1. So then n, so it's just n y to the n minus 1 power. So that's, and then that's just going to be equal to y prime. So that's kind of how we can use implicit differentiation to get the derivatives of these seemingly odd functions, like this. Okay, I hope I didn't confuse you too much, and I hope you learned something. So please come back next time, where we will be working through our final proof of the power rule. So thanks for watching.